Okay, hello guys. So I'm Catalin Luta. I'm currently the engineering manager for the security and performance team, and this is Andrei Tuicu, one of my colleagues in the team, a software development engineer. And we're basically here to present you the great tool that is Toughday. Okay, so first, a bit of background. As you probably know, performance issues are basically the thing that any service wants to avoid. Our problems with it started roughly in 2005 when we had a very, very quirky bug nested deep into our product's code that corrupted all the data if the system was under heavy stress. That's how the first iteration of Toughday was born, basically to replicate and track down the malicious behaviors that reside in our code, and basically it worked like a charm. To begin with, it was built on top of JMeter and Bash, Java, the buzzwords in the industry at the time. As the years went by, the requirements and needs of the customers and engineers alike grew larger. Our test cases grew in complexity as well, spiraling a bit out of control. Due to the large size of the XMLs, customization was rather cumbersome. No source control gave way to corrupted tests and loss of versions, and basically maintenance was expensive. That's why in 2015 we decided to basically switch things up a little bit. It all came together as an internship program that me, Andrei, and Andrei Dulvac, which you'll hear on Wednesday, basically came together and said we need to do something bigger, let's call it. The main focus of the internship was basically multi-threading in performance testing. And we've asked ourselves what exactly would change if everything was code. So that's basically how Toughday 2 started. What exactly is Toughday 2? It's a multi-threaded Java testing framework for performance, longevity, and stress testing. I know that's quite a mouthful, but it was basically the shortest sentence we could come up with to sum it all up. While at the beginning we basically aimed just AEM as a target, it ended up being performance testing framework that is able to target any remote application. What makes it stand out from its peers, let's call them? As I said at the beginning, test as code is one of the most important features. This approach helped us fix the old problems like customization and source control, while bringing aboard new features such as modularization and extensibility. Furthermore, this lets us take advantage of the full power of Java. There's already a vast array of libraries and clients that do all sorts of things, so there's no actual point to reinvent the wheel over and over again. For example, in the case of Sling, we use the Sling testing clients to easily execute requests and things like that. In regards to customization, we've reached for a balance between convention and configuration. We think it's important that the user should be able to configure every tiny bit of the information, parameters and such, but at the same time, we want to make running Toughday a pleasant experience, so we basically have sensible defaults for everything present there. You could basically just download the jar file, run it against your server, and it will work out of the box. We also give other developers the chance to fiddle with our code if they want to. Basically, most of the important things in Toughday are extensible, such as tests, runners, publishers, clients, you name it. And since a while ago, it's open source, so everybody can give it a go. Um, we also had pipeline integration in mind because we're basically lazy people, and we adhere to the Unix philosophy of do one thing and do it well. So basically, we targeted a single jar deployment. We didn't want to overload the framework with additional things. And for example, in our case, we basically run it in a complex pipeline. We have something that an internal tool that takes care of provisioning. Then we have Jenkins for orchestration. Toughday brings the heavy load on the tested service. And then we have Elasticsearch for the shiny reports at the end. Although it has a tiny footprint, as I said, one single jar of approximately, I don't know, 20 megabytes or so, don't disregard it. Toughday puts an emphasis on performance using all the resources that are available. Memory, threads, you name it, as it says there, your resources are belong to us. And of course, it's free, as I said, open source, so sharing is caring. If you want to see how the code looks like, if you want to help out creating either tests or new run modes, it will help everybody. Now let's talk about what Toughday does not want to do. As I said, we wanted to do one thing and do it well. That's performance testing. We didn't want to do reporting because in the case of benchmarking, we basically focused on collection and aggregation of data, which basically means that we measure different kinds of steps in your tests or requests, and we give you some metrics, like, for example, the 90 percentiles and stuff like that. But we leave the visualization, interpretation, drill-down reports to a more specific product, such as Elasticsearch or other things. In terms of provisioning, again, Toughday is a bit needy because it basically assumes you have everything set up when you run it. That means you either have your server up, that you have a machine for Toughday that can handle all of the load that it can generate. That means a lot of memory and CPU power. And the last thing is cleanup. This is a bit problematic because theoretically you could do it. Andrei will show you in his demo later on that you can write some things in order to do cleanup. But in our case, for example, AEMs, there's a lot of things going on in the background after you target it. For example, workflows and such that create a lot of garbage data that is really hard to keep track of and delete. So at the current point, we do not have a cleanup phase for AEM. Now, in order to follow up on Robert's talk about people writing new tools, we basically looked through the span of these 3 years since we started development and tried to keep an eye open on the poster children of the industry when it comes to performance testing. We do want to know that we are not experts in these tools, right? We basically looked at them to try to understand why they work, what's good from them, what's not that good, and try to adapt our tool to these standards. We basically try to keep Toughday as competitive as possible, as I said, and at the end of the day, I'll be quoting the guys from Locust here that basically said we're really just trying to scratch our own itch. Okay, so the items present in the table, again, just want to stress this, are the most important to us. It doesn't mean that those are the only features that the tools mentioned there are capable of. But if we look a little bit, most of them are green for Toughday, of course. Some of them are a bit problematic when we investigated such as the resource usage for Locust, for example, because of Python limitations, you basically ended up having one single slave per processor, and that's not real multi-threading, right? You had a performance loss. When it comes to distribution, and this is something that we want to work on, We don't have currently native clustering, which is basically aggregation into a single point of metrics or other things that you collect. Currently, you can run it distributed, but you basically need to take the logs separately and do something with them. And the most important thing that I want to note from this table is the granular benchmarking, which is basically quite a nifty functionality that we have. Using Mockito, Andrei created some runtime code generation gimmick, which basically lets you measure every step of the test you write. It doesn't have to be just a request. You basically can create a block and actually measure Java functions and methods as well. And you can see them in the report afterwards. So basically, now I'm just going to make the transition to Andrei to show you the live demo.
Hello. So yeah, this is my first time speaking, and since it's 5 o'clock and I know some of you are sleepy, I tried to think, how can I make this more terrifying for myself? So I said, OK, let's do a live coding session, the most edgiest thing a programmer can do on a stage, aside from swords juggling, I guess. OK. So, as Catalin mentioned, we have multiple extension points for Toughday. Just to mention, the ones that are in place right now is the test runners, publishers, and we are going to, in this presentation, show you how to write one very simple test. Oh, sorry. Yay. OK, so creating your project is pretty simple. I have done that beforehand, not that edgy. So it's as simple as adding a parent POM. We created one for Sling specifically. So in this demo, I'm going to show you how to write a test against Sling. We have a ton of AM-centric features that you can find out after the session, but in this one, we're just going to focus on Sling and forget that AM is a Sling application. So I have a Sling server running, which is the standalone jar. And to create a Toughday extension, all you need is to add the parent POM. We have here the Sling Toughday 2 test parent, which has some things that are specific to Sling, the AM Sling clients, which I think were presented in the past adaptTo sessions. And then the parent of this is, of course, the Toughday test parent, where we have the API bundle, API package, and some tests to make sure you're not breaking the DSL. OK, so now let's just write the test, which is pretty straightforward. We have our class, the Sling hello, and we're just going to extend the Sling test base. Let's implement the methods. So this is pretty much it. We have one test method where our test code that it's going to be benchmark will be residing in. And for the new instance method, I'm going to write something down now, and I'm going to explain it later because why not? OK, so for the test method, I'm going to do just a simple GET request to our Sling server. As I said, we are using the Sling clients, which are also open source. And we're just going to do a do get for the index.html. If you want the simplest test possible, then this would be it. we can go home now, I guess, right? Let's look at a few more features before that. So we wanted the Toughday test to look some sort of familiar, so we inspired ourselves from JUnit. That's why you can do a before method. And here, what I'm going to do is just print some log messages. And now an after method. Catalin mentioned the cleanup. This is where you'd probably structure that. And a setup method. And the same log message. So, as you probably guessed by now, the setup method is going to be executed only once before anything else in our test gets executed. Then, every time before and after what's in the test method will have the before and after methods. Let's also add some logging in the test method, and I'm going to use something a bit more fancier here. So I'm going to say that if there is an exception, I want an error. And I also want the stack trace to be included. And if everything is OK, I want a message that says success. And then I have my code here. OK. As Catalin mentioned, so Toughday by default will give you a statistic about how long this took, but we can also have something more granular. And let's add here a call. We have a lot of overrides for this method, the benchmark.measure that you can use in various contexts. In this particular one, I'm going to use this one, request, and then our client, and then the doGet method. And just for example purposes, I'm going to add another one and say sleep time. And then I'll have here a thread.sleep of 40 milliseconds. And this also gives me an opportunity to show you another override. So basically, by using lambdas, you can create any sort of nesting and measure any block of code, of course, within the limits of not going into micro-benchmarking. So anything that's around over 10 milliseconds maybe can be accurately measured. Using this, anything that's below that, you need some specific micro-benchmarking tools, and Toughday does not provide that. Let's see. Is this OK? OK. OK, so this is pretty much the code. And now let's start executing, but not before I explain, as I promised, this method right here. So in order to make Toughday, at least in our heads, easy to use, we wanted you to be able to not care inside of a test if about multi-threading. So we'll create clones of your test object, and Toughday will distribute them on threads. So inside of a specific test, you don't have to care about the multi-threading aspect. So this is how the test lifecycle looks like. So the Toughday starts first and creates one test instance using the default constructor. Then we call the config methods, which I'm going to show you in a second. Creates the test runner, and then the execution starts with the setup. And after the setup, we clone the test depending on the run mode, so that when you execute a test, you can be sure that it's executed only by one thread, and you don't have to add synchronized and things like that, and you don't create any contention inside your test. And as you guessed, you have before test execution, after, before, and so on. So let's go back and add our parameterization. As Catalin mentioned, we wanted it to be easy configurable. That's why you can reuse the code of your test, but you can parameterize it for different use cases. For example, here I have this index.html hard-coded, and I don't like that because I want to be able to reuse this test for any endpoint in my Sling application. So I'm going to add a configuration point with a default value that's going to be my hard-coded value from here. And a description, the path for the request. And I'll create a setter method that will receive this parameter and say this path. And we'll also create a getter, which is going to be useful for us a bit later. Get path. Path. And let's create this field. Of course, now that I've created a field, Toughday, the clones that Toughday creates will no longer know about this configuration. So what I can do is to simply call here in the new instance, I can say Sling hello. And in this way, I have a very granular control about what I pass between the clones, and I can use the entire array of Java mechanisms to do any kind of synchronization or not, depending on the case. OK, this is our test. Now let's start executing. So building it. OK. Let's not run into that problem again. Can you see this? Is it OK? OK. So building it is as simple as running maven clean install. And of course, sorry? Yeah. Perfect. Thanks a lot. As I said, very edgy of me to write live code. Let's try again. Yes. So as you can see here, we have a pretty strict DSL. For example, the final methods here. If I omit this, Toughday will tell me at the build phase, so I don't have to care later when I deploy it and execute it. If I wrote my test correctly, I will know that at build time. So I have my test jar here in the target folder. And here I have the Toughday jar, which is the runner. And now I can do this. So we embedded the documentation in the application itself so that you don't have to leave the command line to go looking into sites where the documentation might get outdated about your test, what are the parameters, and so on. You have them directly in your command line. So let's say I want information about the Sling hello, and add target. We'll let Toughday know about where is our extension. OK, so as you can see here, we have our Sling hello class. We have the fully qualified domain. We don't have any tags or description, but we can easily add those. Description, my first Toughday test. Now if I rebuild, and rerun, I have here my description. So in this way, it's very easy to keep in sync your implementation with your documentation about the test. And now let's try to execute it. So we'll just add it. Hello. We are going to specify the host, the port, and where exactly is our extension jar, and one last relic that we have that's connected to AEM, which we'll have to remove. We have to stay install sample content false. Let's first do a dry run to see if everything works correctly. So the dry run will print me everything, every object that Toughday is configuring and how. And we can see here our test Sling hello with the configuration that we specified, which are the defaults. And now we can execute it. And it passes. So as you can see, we have a lot of requests, 500 requests per second. It's actually 500 test execution per second because we also have that slip. This is what we call the aggregated view for our data. And we also have a more detailed view. We called it the raw view, where I can see every single execution that's being benchmarked, and I can aggregate these on my own and extract any kind of metrics that I want. So for example, here, I have the Sling hello test, which passed, and it took 58 milliseconds. And then I have my request, which, as you can see here, has also some additional metadata because we wrote some interceptors for the clients. I'm not going to get into those interceptors in this presentation because that will take a lot of time, but basically, you can write them for any client, any Java code, And that's how Toughday is not linked to any sort of client or application. And we are intercepting here the URL, the method, the response code, bytes, latency, and what user did the request. And we also have the sleep time. So basically, we have these two separately benchmarked and the total of the test. And I can nest this in any way that I want, and so on. Cool. So let's now use the path that we configured. So by default, as you've seen here in the results file, we are doing request to index.html. And now let's change that. Let's say that the path is content.html. And similarly, Toughday will execute. It will target the new endpoint. And when we look into the new results, we'll see that now we have content.html. As you can see, Toughday uses a lot of conventions, a lot of sensible defaults, but I can change any of these. For example, it uses by default 200 threads on the what we call normal run mode. Yes, I know, very specific naming, tells you a lot about it. But we can change that. So I can say here run mode type normal. And instead of using 200 threads, I can say that I want just 100. And we'll have less requests. Of course, we can also give more. And let's also try a different run mode, which is called constant load. So on the normal run mode, we have a constant number of threads executing as many tests as they can. But we can say, I want this number of test executions. Please scale the threads accordingly in the background for me. So let's say that I want to have 50 executions per second. I can do that like this. So now Toughday is going to start 50 executions per second. And what you see here is how many responses we get. Of course, this will eventually converge to the 50 executions per second that we specified. So we've seen how to write tests, how to configure them, how to execute, how to play around with the configurations. We have a lot more. For example, you can remove any of these metrics and add new ones. If you don't like the 99 percentile, you can get the 80 percentile, and so on. Two last things I want to show you, which are the logs. So for every execution, you get a separate log folder with your timestamp, and you can see here for every test we have on file, and you can see here the messages that we printed out in the logging. So of course, I can add the Sling test multiple times, targeting different endpoints, and with a different naming, we'll have a different file. And last thing, for every execution that you do, Toughday will generate a configuration file for you so that you don't have to do it from the command line every time. And of course, you can write such a file yourself. It's in the YAML format, so pretty easy to do. I have prepared also one up front. And to execute it using this, all you have to do is say java-jar config file equals and instead of taking the arguments from the command line, it will read them from the file, and if, of course, you can overlay them. You can add to the tests from the file, you can remove, you can change parameters, and so on. If you want to play with this example, we'll have tomorrow our playground session, and it's also in GitHub, where I don't have connection to the internet, but it's right here on this URL. You can download it, you can build it, you can execute it, you can play with it. And now I'll invite Catalin back to say a few more words.
Thank you. OK, so you basically have QR codes for all of the links that we have. You can just scan them, and it will take you to wherever you need. OK, so the last thing that I wanted to talk about a little bit is what's coming next. First of all, I wanted to say that basically in this demo, we didn't get to touch everything that Toughday does. For example, how to write composite tests. Basically, we've created the idea that you have standalone tests like the get one that we currently had, and then you can inherit that and use it as a step in a larger use case, for example. We have weights, which basically means how exactly they get executed, and a lot more features that you can get to explore when you're going to play tomorrow with it. And what's up to come next? So basically, we want to implement some feeders, which is basically a term that we kind of stole from Gatling a little bit. Imagine if you want a bird feeder in which the seeds go in, the bird eats from one point, but it doesn't know exactly where the food is coming from. This is what we basically want to implement for our tests as well, mainly because we want to have inner test communication, which would be a bit agnostic, not knowing where the information is coming for. They just want asset ingestion or something like that, and they will use it no matter where it comes from. The other thing that we're currently working on is the headless browser support, because we saw a lot of requests in the industry for actual page loads. And currently, most of the frameworks that do this offer some sort of estimation, let's call it, not exactly executing the JavaScript code completely and stuff like that. We also want to implement phases, which would basically allow you to configure better the longevity test cases, where you won't be basically just running the same gets for a span of 7 days, but you will be able to configure the actual load based on user models. So you'll have higher loads in the evening, you're gonna have lower loads in the morning and stuff like that. And where you can visit us, we basically have the homepage on GitHub under the Adobe organization. You have a link to our repository and a link to our documentation. And that was basically it. I hope we see you tomorrow in our workshop to get to try Toughday. And if there are any questions, we're open to answer them. Thank you.
So any questions?
So these tests are all based on running against an actual AEM instance or a Sling instance, but most of the times you also have a dispatcher there. Is there anything in there to also use the dispatcher?
Yes, so Toughday does not know against what you are using, against what you are executing the requests. So you can put a dispatcher in front, you can give it the endpoint to the dispatcher, and then you can also see how your caching is performing and so on. So Toughday is completely client-side. It has no idea what the application is on the server side. It's not tied to AEM, Sling, anything. You can even use it to test your Mongo database.
Any further questions? There's one over there.
Hello. Do you have any plans for some kind of parsing of the HTML that you get back to decide, okay, I also need to have these CSS files or JavaScript files downloaded? Or do you have something like a future version of Toughday to contain some kind of proxy to record sessions?
So first for the sessions, I don't think we have any plans for that, mostly because we want to keep Toughday completely agnostic, so not knowing even if those are HTML requests, HTTP requests, so maybe other protocols don't have sessions, but of course you can, so as you saw, you can have metadata aside from what Toughday gives you out of the box, like you saw with the URL and the method, and you can compute those in the code in the test, and you can have them directly in your results. And to download, I hope I understood correctly the other question. So not doing just a get, but also downloading all the resources and stuff like that. Yes, that's the real browser support that Catalin mentioned that we would like to have. So we want you to be able to see how a get performs, how a full page load performs without the JavaScript, and also the third layer, page load with JavaScript on load executed. So you can have this very thin layering of for your requests.
Any further questions? There's one over here.
Hi. I'm interested in, is there a plan to support Cucumber to define tests?
I'm sorry, can you?
To support Cucumber, you said?
Cucumber to define test cases?
Okay, we looked a bit into it, so it's not in our immediate plan. We are thinking about it, but we can't give you an estimate when it's going to be implemented or if. So we're currently just looking at the possibility.
Okay, thank you.
Any last question? Okay. Then thank you for your presentation.